Alright, one-sided limits. So this is the video that to test your understanding about does the limits of x approaching -1 for this function exist, right? So we don't know whether it exists or not. So as this is a modulus function, for every modulus function that when you substitute the -1 here, you have 1 minus 1, you're getting 0, right? If you do direct substitution, you test the function, you have 1, you're getting 0, and you put -1 plus 1, modulus of 0, you're getting 0. So this is a case where there is undefined, right? So we have to, if there is a modulus case, if there is a modulus here, to determine whether this limit exists or not, we have to consider, because this you have modulus, so you have to consider right hand side and left hand side. Okay, means that you have to consider both sides. The limit of one-sided, you have to consider limit as x approaching -1 from the right for this function. Okay, and from the left, you have to consider both sides. So consider limits x approaching from the left. So very simple. If these two value, after you evaluate the left hand limits and the right hand limits have the same value, then these two exist. There is a value that represents this. Okay, -1 from the right, from the left. So now, very easy. Let's move on to the very basic of concept of modulus. So you have to know that modulus of x plus 1 is defined as positive x plus 1 and negative x plus 1 for x greater equal positive 1, -1, and x less than -1, right? Based on this definition here. So then now we consider, using this definition, we consider the limits. Let's look at this. -1 plus. -1 plus means it's a number that greater than -1, right? Greater than -1. So greater than -1. So I have to rewrite this as x plus 1. Okay, so means that limits as x approaching -1 plus, this one I can rewrite as x plus 1. So x squared plus -1, you know that x squared minus 1, there is a factor x plus 1, right? There is a factor x plus 1 when you factorize. So which you can doing division for this one. And you put negative inside your -1, you have -2. So the right hand limit for this function, you're getting -2 for -1. The left hand limit for -1, the x equals to -1, approaching x from the left of -1. So -1 from the left means a number that less than -1. So okay, this one I can factorize directly, x minus 1, x plus 1, and modulus x plus 1 you can replace as negative x plus 1, right? So you do, then you have negative, substitute the negative, -1 minus 1, you will have -2, +2. As you see that the limit for the left of -1, you're getting 2 for the same function. And from the right, you're getting -2. So this shows that the limits for x approaching -1 for x squared minus 1 modulus x plus 1 does not exist. So this is the concept of algebra. There is also a concept of graphical. Means that you can represent this information here by using graph here. So limit does not exist in mathematics. We usually talk about the graph is separated, means that this graph is not continuous. They are not joining. So they are breaking, okay? They are discontinuous, where there is a case that the limit does not exceed, means these 2 points have two different values at the same point. At the same point, they have two different values. So for this case, the y value here, you are getting -2. From the right, you're getting -2. From the left, you're getting 2. Means that the graph is breaking, okay? It's actually not joining, all right? This is the graphical meaning, right? Graphical meaning. So algebraically, if these two have different value, the limit does not exist. All right, that's all for this one-sided limit, the concept of one-sided limits.